In this example, we're going to look at thermal volume expansion of solids and liquids. So let's begin. A 100-liter tank of gas on a certain truck is filled to the brim with gasoline at 20 degrees Celsius. On a very hot day, the tank reaches a temperature of 35 degrees Celsius. Assuming the tank is made of steel, calculate how much of the gasoline in terms of volume will overflow if the car remains parked. That is, the car doesn't actually spend any of the gas. So let's begin by looking at the following two diagrams. In diagram A, we have a depiction of our steel tank, and inside the steel tank, we have the gasoline. Now, the gasoline is filled to the top of our steel tank, and the gasoline and the tank are at the same temperature given by 20 degrees Celsius. Now, on a very hot day, the tank and our gasoline both expand. So we go from 20 degrees Celsius to 35 degrees Celsius. Now, because the gasoline expands at a faster rate than our steel tank, some of that gasoline will end up overflowing because, as I said earlier, our gasoline is filled to the brim, to the top of our tank. So we're going to solve this problem in 3 steps. In the first step, we want to find the change in volume of our gasoline. In step 2, we want to find the change in volume of our steel tank. And in step 3, we're going to find the difference to calculate what our volume of gasoline that actually overflows. So let's begin. So we need to use the following equation for thermal volume expansion of liquids. So change in volume of the gasoline is equal to the product of these 3 factors. We have the change in temperature, the final temperature minus the initial temperature, multiplied by the initial volume of our object or substance, multiplied by the coefficient of volume expansion. Now, this value we can look up in a textbook or online, and it turns out to be 950 times 10 to the negative 6 Celsius to the negative 1. So we multiply this times initial volume of 100 liters because the tank is filled to the brim, multiplied by our final temperature of 35 minus initial temperature of 20. So we get a difference of 15 degrees Celsius. So 15 times 100 times this gives us 1.425 liters. This is by how much our gasoline expands. Now let's move on to the change in volume of the steel tank. So, in the same exact way, we use this same formula, except now we replace our beta gas with beta steel. So this is the coefficient of volume expansion for steel. So once again, we can look this value up in a textbook. We get 12 times 10 to the negative 6 multiplied by 100 multiplied by 35 minus 20, or 15 degrees Celsius, and we get 0.018 liters is by how much our steel tank expands. Now, to find how much of our gasoline overflows, we simply take the difference. We say our change in volume overflow is equal to the change in volume of the gas minus the change in volume of the tank. So, 1.425 liters minus 0.018 liters gives us 1.407 liters is the volume of the gasoline that overflows as a result of the fact that our liquid, the gasoline, expands at a faster rate than our steel tank, our solid object.